Chris, it's all yours. Let's begin. And I will monitor Q&A for everybody.
Great, Brad. Thank you so much. And just confirming, my voice coming through okay?
Yep, it's loud and clear, Chris.
Okay, great. Thank you and welcome everyone. So first item in this discussion is a similar question that I asked if you happen to attend any of the prior discussions, which is in the area of a data network, where's the best place to put network security? And I have here just a simple drawing. Don't take the details of the drawing too literally, but a good place, where should it be? Example, let's say we have internet connectivity coming in at a certain point, and clearly there should be a firewall connecting in. Okay, that's pretty obvious. But what about after somebody's connected in? Or what if somebody walks in the environment with a computer, a network device, a laptop, whatever it might be? Question, what do they have access to? And where's a good place to put network security? Well, 20, 30 years ago, the traditional answer was we typically just have security at internet facing with a firewall. Okay, question remains, what's a good place to put it? The current answer is everywhere. Security should not be on this device or that device, but the best place to have security is everywhere. Simple reason, hackers, criminals, viruses, malware, all these things, they're only getting smarter by the criminals and people with bad intentions that try to put any network or network data at risk. So the goal is to get smarter than them and lock down security, ideally everywhere. So the last discussion we had was on network security in the campus. Our discussion here is all about in the data center. And Cisco's premier approach to achieve that is with application-centric infrastructure, Cisco ACI. So ACI came out by Cisco in April 2013. It was when it debuted in ACI version 1.0. Currently, we're in the ACI 5.x versions overall. If I were to draw a little line down here, to the right of the line is traditional networking. So a key question, if I were to take a computer like Windows, Linux, whatever it might be, A, and plug in another computer B here. I have the network Nexus operating system. To the right of the line here, this is pre-ACI. All right, simple question. What does it take for A to connect to B? I mean, what do we have to do? Not a trick question. Pretty much the answer is nothing. If A is simply plugged into B, A is simply plugged in the switches, the connectivity will allow it to come through. Whether I have routing or switching, there's really nothing to do. It's real easy now, isn't it? This, by definition, is called a blacklist model. So a blacklist model by definition means you plug a computer in, you're on the network. Connectivity is easy. But security is very poor. Because what if A is a hacker, has a virus, has inappropriate software, anything which is not allowed or shouldn't be on the data network? If it's on the network here, a blacklist model of networking lets it send all the way through. Blacklist says, hey, whatever you got, that virus, that hacking attempt, come on through. You can go anywhere. Easy to work, terrible for security. So ACI on the left of the line here is always the exact opposite. It is a blacklist model. Cisco ACI is the extreme opposite. It is a whitelist model. So a whitelist model by definition means if I have an end node computer and I plug it in and I plug another computer in, by default, they have no connectivity. Literally, I plug in a computer, I want to ping B. It's not going to happen because everything is secure by default. A whitelist model means when you plug it in, nothing works. No ping. Can't get to the internet. Can't check your email. Can't get to a web server. Nothing works at all in a whitelist model until we do an action of putting it in a whitelist. This is a little more complex, but far more secure. The issue with the whitelist model is everything that we forget, ACI remembers and blocks. Analogy, what is the last line of an access control list? Implicit deny. It's always been that way. In ACI, everything you forget, it remembers and blocks. So that's the idea of a whitelist. The only thing that will connect is what we allow it to connect. Worded another way, in any data network, there's always two top-level approaches. What do we allow to connect? What do we allow to isolate? If you want to get to the web server, of course, we better be able to connect to it. If we have an email server, we want to make it available, better connect to it, obvious. But again, if everything can connect to everything, data level security is much less. So, two approaches for that: blacklist, the traditional way on the right; whitelist, the newer way in ACI on the left. The whitelist is our focus here, as that is not only critical in ACI, but allows for a very high level of security. Hackers, criminals, cyber thieves, they don't like a whitelist model, because if you and I forget anything, ACI remembers and blocks them out. It's like if I forget my keys to the house, well, that'd be pretty bad for your home security. But what if your home security got infinitely secure if you forgot your keys and locked everything down automatically? Analogy, that's what a whitelist actually does. So ACI always has three key components: spine, leaf, and a server called an APIC. ACI is doing what's called software-defined networking. Software-defined networking implies we have to have a controller. In ACI, that's called an application policy infrastructure controller. It's a server that must plug into the leaf, as you'll see in the next drawing. So where do we configure the whitelist? Always in the APIC. So can I connect into the spine? Oh, sure. But can you configure the spine in the spine? No way, can't even be done in ACI. Can I PuTTY or SSH into a leaf? Of course you can. You can type show commands and see what's going on, but you cannot configure the leaf in the leaf. So everything in ACI, the whitelist, is always done in the server. What if we don't have an APIC? Then you don't have ACI. It's that simple. You must have the three pieces: spine, leaf, and an APIC. Same in production, same in a lab environment, same in a classroom environment. So here's an example of a simple example of ACI. And what you and I would do is start off in Windows or Linux, and we would connect to the APIC. This is called the northbound connection. In software-defined networking, this is the northbound connection. All security and the whitelist is done in the north. This can be done with a web browser, command line interface, or a programming language like Python, but it's always and only done in the north. Which APIC do we connect to? Never matters, because every APIC automatically replicates its content with every other APIC with a database replication technology called sharding, S-H-A-R-D. Sharding is a way that the database is replicated automatically between them, and that's automatically turned on in ACI. Okay, next, if we make the change to the APIC, how does the change get to the spine and the leaf? Well, in software-defined networking, this is called a southbound protocol. The southbound protocol goes from the APIC to every other device, always and automatically. In ACI, Cisco created its own protocol called OpFlex. Cisco made up term and protocol. OPFLEX, OpFlex. OpFlex is a southbound protocol. What you and I do when we administer ACI is nothing in the south. There's nothing to do. OpFlex is done for us by ACI. How do you configure OpFlex? You can't, you never will. OpFlex is always there and automatically there. So you and I configure the whitelist in the north, then ACI configures that whitelist setting everywhere. Next, where do we plug in everything to ACI? In ACI, this is called a pod, or a point of delivery. It means a group of spines and leaves together. So end node devices never get plugged into the spine. They only always get plugged into the leaf. So example, I have a Windows server. It's in the data center, want to make that available, plug it in the leaf. I have a Linux server. It gets plugged in the leaf anywhere you like. I have a VMware server. Same thing, it'll get plugged into a leaf. Here I'm showing single homing, whereas ideally we would do multi-homing, connecting the two different devices. This would imply a port channel connection right over here. Okay, but whatever connection we want to do, another router, another switch, a load balancer, a firewall, another virtual machine, Microsoft Hyper-V, Linux, Windows, a Cisco UCS server. They get plugged in the leaf, but never the spine. However, as soon as you plug them in, once again, what can they do? Nothing. Literally. Hey, I bought a data center with ACI. I plug in an end node computer. It's going nowhere. No ping will work. No protocol will work. Everything is stop cold right there by default until you and I do a whitelist. A whitelist is literally a drawing. Here's an example of what one looks like. We start off in the whitelist and we create a tenant. A tenant is real easy to create. It's like a logical entity, which could be your company name, an organizational name, a new company you bought, a project we're on. These are examples of things we might make a tenant from. But if we don't make any tenants, there's no place to put a whitelist. And if we don't have a whitelist, then the whole data center doesn't work at all. So we must do this at least initially. Underneath the tenant, the next thing we'll create is an application profile. It's real easy to create these. You simply highlight the right setting for tenant, right mouse click, add new tenant, give it a name, press submit, you're done. A tenant can be created in about 5 seconds if you're taking your time going slowly. Same with an application profile. Underneath that is where we would create the first object of the whitelist called an endpoint group or an EPG. Every whitelist must have a minimum of a tenant, an application profile, and at least one endpoint group. If you don't do at least that, the servers in the data center, they won't go anywhere. All connection would be dropped unless we have at least one way to connect through, and that is at least an EPG. Analogy, an endpoint group is kind of like a VLAN. They're not the same, but similar. So if I have a computer here like Web 1 and another computer like Web 2, what would be their default connectivity if they're in the same EPG? Well, the question would be like, what would be their default connectivity if they're in the same VLAN? If they're in the same VLAN, they have full connectivity to each other. Same with EPG. So these two computers can fully talk to each other if we put them in the same endpoint group. Everything in this drawing is the whitelist, and it's logical. It's all in software. Where does it get applied? Well, everywhere in the hardware. Next, a whitelist in ACI is not based out of IP addressing. I'll say that again. The whitelist is not based out of IP addressing. Example, if you've configured a firewall of any product, you've obviously configured IP addressing, subnets, host names, whatever it might be. If you configure a router access control list, you're always configuring IP addressing, host names, subnets, whatever it might be. But in ACI, the whitelist is not based out of IP addressing. We are centered around applications. Note the name, application-centric infrastructure. Security is focused around the application. And what kind of application are we talking about? Anything that you plug into the leaf. So if I step back here a moment, what do we need to get application support in ACI? Couldn't be easier. An Ethernet cable, plug it in the leaf. All right, we have an application we're talking about. Anything, any server, any product, any operating system, any protocol, any port, you name it. Got an Ethernet cable? You're an endpoint in ACI, but if you're going to talk, you've got to be in the whitelist like we see here. So another example, could I have another server here that has like an IP address of 216.4.8.1, and it's a web server, and there's another web server at 10.01.11, and they're in the same EPG. Can you do that? Sure can. Will they have full connectivity to each other? Yes, they will. I wouldn't recommend IP addressing that's sloppy or unorganized. No one would. But ACI doesn't care. The whitelist is not based out of IP addressing. So in this example, these two devices, who cares what their IP addresses are? They'll be able to communicate to each other only because they're in the same endpoint group. Okay, next, what if I have a computer here in the web endpoint group, and we make another endpoint group for, let's say, some kind of application. The application could be anything, Microsoft SharePoint, a server running some Java code that we've created, a custom application for a call center. Could be anything you like. It's just a made-up name here. The word app could be anything. That's a made-up name. All right, so now, what is the default connectivity between the app and the web server? And the answer is nothing. If you're in a different endpoint group, you have no connectivity to each other. Well, in the VLAN world, if we wanted to connect a VLAN to another VLAN prior to ACI, we would do inter-VLAN routing. Not so in ACI. If you want to get from one endpoint group to another, there's a new technique called a contract. A contract is logical. It's software. It's kind of like doing inter-VLAN routing with a new name. A contract is like a virtual cable. You plug it in one end, you plug it in the other. A contract by default can be empty, but then it won't work. To make it do something, we would link it to something like a filter. A filter, example here with ICMP and web traffic, a filter is like an extended access control list with no IP addressing. Filters do not care about IP addressing. So in this example, if the web server were to contact the app, the only traffic that it could come through is with ICMP or HTTP in this example. Of course, we could choose any TCP port and or any UDP port and or any protocol running on IP and or any protocol that could ever run on Ethernet. Anything could be in a contract. The filter is built into ACI, meaning you don't have to buy another product for that. However, a filter should not be thought of as a replacement for a firewall, but it does a lot of firewall features when it comes to packet filtering. But if you need a full higher level security, then you could do what's called a layer 4 through 7 service. In ACI, we're saying the same thing. Service, layer 4 through 7. This means you buy another product, like an F5 load balancer, or Citrix NetScaler, or a Cisco ACI firewall, or Cisco Firepower, or a Palo Alto device, or a Juniper firewall, anything with an Ethernet cable. That's what we're talking about right here. Just plug it in with the Ethernet cable, and then this drawing here says if the application server wants to send any traffic to the database, the only way that's going to happen is if you go through the firewall. Notice we're insisting you go through the firewall. This whitelist demands all network traffic. Nothing will happen in the network unless it's in this drawing right here. Next, notice right now, if we want to connect to the outside world, meaning outside of ACI, we'll do what's called an L3 out. This means connect to routers on the outside. These routers could be BGP, OSPF, EIGRP, any traditional routing protocol. L3 out means go to any routed network, like the whole internet, your campus network, another data center, another location, another customer, whatever it may be. It's just we're going to use routing to get out. And then this object, again, we would have a contract. In this example, we're plugging in a firewall. Again, this would be a physical firewall because it would be a service. Again, could this firepower here replace the ASA over here? Of course it could. Could these firewalls be the same physical device? They sure could. Could they be different? Okay, they can be different as well. It's whatever you like. It's literally make a drawing. Security in an ACI data center, make a drawing like you see here. And it looks in ACI like a drawing. And then it becomes the master source of truth for any form of IP connectivity. So example, let's say I'm somebody here on computer Q. I'm sitting in a coffee shop. I'm way outside our data center here. I do have connectivity to the internet, like anyone would from a open, being at home, a coffee shop, wherever it might be. This then would connect through L3 out inside. Study the whitelist. If Q here happens to be a hacker, or is doing a port scan, or is trying to learn about your network to hack into, question, how far can they hack into? Clue, read the drawing. And the answer is they can only get to the web server with whatever we're allowing in the firewall. Notice they have no way of learning about the app server or our database because it's on the drawing. There's not an exact contract like this. We could put them one there if we needed it, but if we didn't have one there, that connectivity will not go through. Worded another way, if you have a production database, like an Oracle database, Microsoft SQL Server, MySQL, whatever it may be, how much would you want that database to be openly exposed to the internet? How about never? Which is easily achieved, like you see here. Because if I don't have the contract from the outside coming in, there's no way to get there. The logic is not transitive. So just because the web can see the app and the app can see the database does not mean the web can see the database. Logic is not transitive in an ACI whitelist. So this is one example of a drawing, but this drawing can be very big or very small. If you make the drawing simpler, it's a lot easier and not as secure. Easy and security are the opposite. An easy drawing, in fact, the easiest drawing, I could make one EPG and call it everything or all, and put every server in the whole data center in the one EPG. And then they all have full connectivity to each other. That's real easy, but terribly unsecure. Because if one server got breached, then ACI allows that connectivity to everything else. Easy and security are opposites. So a better approach is make more endpoint groups that center around the application. This is more complex, way more secure. So in the highest then, what would be the most highest secure ACI data center? Let's say we have 500 computers. I could make a EPG for every one of the 500 computers. Then any computer can only talk to another computer if we specifically state it in the whitelist. In better words, all traffic that needs to go through, all right, let's let it go through. But everything else that doesn't need to work, let's isolate it. Let the good guys in, keep the bad guys out. Worded another way, if you identify any traffic in a data network that does not need to happen for a business productive reason, and you block it, you're not hurting business because it wasn't needed there. But if we isolate that kind of traffic, we're always making the network more secure. So the two extremes of ACI is make one EPG, put the whole data center in it. On the other end, if we have one EPG for every individual computer, that is very, very secure and not easy because this drawing can be complex. What if we forget a protocol? If you've ever configured a firewall, you probably noticed if you have some type of computer that's got to talk to another computer, you better know exactly what TCP and UDP ports are used. Because if you forget one and you're blocking everything else, you just broke that application's connectivity. Same in a firewall, same in an access control list, same in a whitelist. It's just that everything we forget, it remembers and blocks. Okay, next, here I'm showing another example of how ACI could exist with some more hardware pieces. So once again, let's say I'm computer Q over here, and we have a web server over here. And I decide to put a firewall over here. My application server is inside UCS over here. And over here, I decide to put my Oracle databases. And over here is my F5 load balancer. So what if I insist that when the traffic comes in, it must go first to the F5 load balancer and the firewall, then to the web server. That then goes to the application server. That then connects to the database. How do you guarantee the traffic flow inside here? You don't answer the question in the hardware. You do answer the question in the drawing, as shown here. The whitelist will determine the exact flow of traffic. So in this example, not the only way of doing things, but if the web server wants to go to the app server, it will not go through the firewall because it's not in the drawing. Very little this drawing is. But if the app server wants to go to the database, it must go through the firewall. It has to go through there because that's what shows up in the drawing. So it doesn't matter where we plug these things in, it must go through there. Another common question is, well, wait a second, doesn't that mean we might have a lot of traffic that goes back and forth and back and forth and back and forth? Sure does. Is that slow or inefficient? Not at all. The reason is the pod or point of delivery is always equal cost multipathing, always. What that means is if I want to have traffic coming through from A to B, if it's in the whitelist that allows it, which way will the traffic go? Notice I could go this way, or I could go this way. The fact that you can go both ways, well, in ACI, it's always equal cost multipathing. We go both ways, always. This way, if one spine goes down, we simply use the other one. If both spine goes down, that's terrible. We have a big outage. If that concerns you, well, buy another spine and have more fault tolerance. Notice the cabling in ACI is we never plug spine into spine. We never plug leaf into leaf. Instead, every leaf must be plugged in every spine. And the slowest speed you could ever get was 40 gigabit per second. Several years back, now all ACI, each cable is 100 gigabit per second. So what if I plugged in another cable like this, started plugging in more cables, and let's say added 3 more spines. Just plug in the cables, spine to leaf. And I won't do every one in my drawing, but let's assume that every spine connects to every leaf. And we have 100 gigabit connection here with 5 spines and 2 connections each. That now has taken us up to 1 terabit per second. Massive bandwidth is real easy in ACI with a spine and leaf topology. Not high bandwidth, but massive bandwidth. Any data network always has a bottleneck. It's not going to be here. More likely, it's somewhere on the wide area network. But in terms of performance, ACI is not going to be the bottleneck because it's so easy to give massive bandwidth so effortless. And the whitelist simply says, oh, you gave me more bandwidth? Sounds great. I'll use it. Notice when you configure the whitelist, it does not care about how many cables you have plugged in. It doesn't care about the hardware. It just cares the hardware works. How well does it work? Plug in more cables, get more spines, and you have more bandwidth to share. Okay, next is a little typo in the cabling here, but if I were to configure ACI with virtual port channel, this connection would come out to an external router as I show here. If I wanted UCS to be in a virtual port channel, assuming I want to multi-home, assuming I'm doing port channel right here, assuming I want to take advantage of VPC, then what you cannot do is overlap the VPC domains. This third one I've drawn is not possible, not legal. So technically, this cable right here would need to connect right over here. So now I make one virtual port channel domain here and another one here. How does this change the whitelist? Not at all, other than we're connecting in a virtual port channel as opposed to just an individual cable. But the whitelist itself stays the exact same thing. So the underlying architecture does not change. Okay, now we say, wait a second, our data center is growing. We just need another 500 new servers. What do we do? Do we have to redesign everything? Not at all. If you want the data center to get bigger, you go left and right, which is east, west. We don't go and make a 3-layer model. Notice it's always spine and leaf. So we'll never make a third layer. In better words, the idea of core distribution access does not apply in ACI. Want to make it bigger? Go left, right. Add more leaves. Concerned about a spine going down? Money fixes a lot of things with fault tolerance. Buy more spines. Always plug every leaf into every spine. Okay, so after the hardware is plugged in, how do we get the new whitelist that we've created onto the spines and the leaves? Answer, do nothing. It's always automated. The Southbound Protocol, Flex, will realize, hey, you got a new leaf. Here's all you need to know. For the tenant, application profile, contract, subject filter. It just does everything. It puts it all on automatically. This again is software-defined networking. What are the networking elements? We need hardware, of course, but all the magic is done in software, which we do on the APIC. Next, in ACI, there is a database called the MIT, Management Information Tree. That's the name of the database Cisco gave. So it's not an Oracle database. It's not a IBM Informix database. It is called the Management Information Tree. When you get ACI, you don't have to install the MIT. It's built in already. Can you replace the database? No. Can the database be external? Nope. Can you link it up with Oracle? Nope, and you don't need to. It's fully ready as a database. And what's in this database? Every setting of security in a data network inside ACI. It's everything. It's a big database. And every item in the database is called an MO, or a managed object. So this drawing shows a tenant example has what's called a 1-to-N relationship with an application profile. This means you can have several application profile. How many of these would you have? Well, study the applications actually being used in production. Example, the one I showed is a 3-tiered application where a web server talks to an application server that can then talk to a database. That's one example of an application profile. Another one, notice it's 1-to-N. That means I could have more of these in a tenant. Another example might be all collaboration or unified communication servers, like voicemail, call control, a call center device, Cisco emergency responder for E911. All these things share in common a common use of applications. All right, so put them in the same application profile. What about finance and accounting, billing, treasury, all those type of things, and applications for finance? That could be another example of an application profile. The next thing is, what is a layer 2 switch in ACI? Well, it's all software, and it has a new name called a bridge domain. A bridge domain is a layer 2 switch that's inside ACI. And every bridge domain, as you see here, must have a connection to an endpoint group. Analogy, didn't we always take a layer 2 switch and put a VLAN in it? Analogy, that's what we just did here. With new names, the endpoint group must have a connection to a bridge domain. A router in ACI has a new name. It's called a VRF, Virtual Routing and Forwarding. Didn't we always take a switch and plug it into a router? Note the same thing here. We're simply interconnecting them together here and connecting this here. Okay, next one, if I step back here, if I have computer A over here, a Windows virtual machine running inside UCS, where is its default gateway? Traditional answer used to be something like here or here, but not so in ACI. In ACI, the default gateway is always everywhere. So computer A virtual machine's default gateway is here, and it's here, and it's here, and it's here. It's in any cast address with a new name called a subnet. So if I have a Windows machine, I put it in an endpoint group that's in a bridge domain that connects to a subnet. That's the default gateway. It's fault tolerant and reliable. Example, in traditional networking, we've always had protocols like a first hop redundancy protocol, FHRP. Example like hot standby routing protocol. Or gateway load balancing protocol or virtual router redundancy protocol. In these examples, you don't need them because it's all done in a subnet. A subnet is doing the same job of providing a fault tolerant default gateway for all our end node devices. And it's very fault tolerant in that it will be available everywhere. Want to install another 100 leafs? Okay, it's on there, all of there, and that quickly. There's no other task to do there. It just becomes available everywhere. So the drawing of the whitelist is available everywhere. Okay, I see a good question here. Who administers the ACI? Cisco owner or both? Good question. Typically, the owner of the data center administers ACI. That's usually the answer. So example, let's say I'm a pharmaceutical company, an airline, a bank. What I'll do in my data center is buy ACI. So my internal IT staff would typically manage ACI. Second example is, what if we want to set up a company and be a cloud provider? ACI could make that as a cloud provider. So we want to be our own cloud provider, providing a specific service, kind of like Amazon does, or the Google Cloud does, or any cloud provider does. We can make our own with ACI. And then we could have different companies or customers. Well, we just put them in a different tenant. We don't have to buy different hardware for them. In this case, the manager would be the IT staff managing ACI in a cloud model for the purpose of our tenants. Yeah, AJ, thank you. Good question there. So the owner of the data center typically manages ACI. A third answer, consulting companies or service providers could offer a service to manage ACI in someone else's data center. That would be a valid answer as well. So whoever buys the technology, they can decide how they want to manage it. ACI allows it to go either way. All we have to do, if I step back over here, is breaking open a Windows server or a Linux or an Apple product, whatever you prefer, open up a web browser, connect to the APIC, provide the proper username and credentials. Of course, we have to have a secure access. And you're the person that allows to do all the management. Yeah, it's pretty cool, AJ. I see your comment there. And there's a lot of flexibility in how the product could go. Here's another definition I like. What is a good definition of cloud computing? I like the definition of using somebody else's computers. What computers do they have? Same computers you might have. And those computers, by definition, could be provided by ACI. So ACI could be the cloud. It could be a private cloud, a public cloud. Whoever buys the hardware gets to manage it. The things that are purchased are the spines, the leafs, the APIC. This hardware must come from Cisco. No third-party product is allowed for a spine or leaf, and that makes ACI. Once you've bought it, then all of the whitelist is configured by whoever has access inside here. And again, if you don't want people to have access, you just don't give them the password to the APIC. The default high-level user is called admin, and the admin user account, by definition, has full rights to everything. And ACI also, to take that last question further, supports RBAC. RBAC, by definition, role-based access control. Okay, what RBAC is doing is we could have any user like Joe that connects in here, and he can do everything. Frank can do a little. Sam, I'm just making this up as I go, but that's what RBAC is. Sam, we could let only be a third-level help support desk just to gather diagnostic information. Okay, role-based access control is built into ACI. Okay, but if you don't do it, then everyone that's the admin user can do everything. So the admin user can create the whitelist, delete it, change it, modify it, create it any way you want. Whitelist is per tenant. So every tenant will have its own whitelist. Where are the tenants here? Simple. Always everywhere. Literally. They're here, and they're here, and they're here, because that's what the Southpaw Protocol does. It takes the content and copies it everywhere. Okay, and again, all these are logical entities. These are all logical, which means we do them in software. The management information tree is a database that has managed objects that you and I would set up for ACI. It's all logical and it's software, and it gets applied on all the hardware. Here's another analogy here. If I step back right over here, what if I took a physical switch like a Nexus 7000 switch? These debuted around 13 years ago before ACI. Well, as an analogy, in a Nexus 7000 switch, where's the brain? Well, it's called the supervisor card. What if that goes down? Let's have another one. Analogy, the supervisor card is like the APIC. Where do we plug in all the computers? These are called line cards. Well, a line card is like a leaf. In the back of the Nexus 7000, there is a backplane called a fabric module. This creates the speed inside the switch, moving packets really fast. Analogy, that's the spine. Spine is like the backplane. Leaf is like a line card. APIC is like the supervisor card. There are different physical devices in ACI, but they act like they're one. So when you configure a whitelist, you assume all of this is one giant switch. You don't think of these things as different. Of course, they really are different. This leaf is not the same hardware as this leaf, but logically in ACI, they're exactly the same. So this logical model applies to any of them. Benefit, I can make a data center so secure, hackers and criminals bring them to tears. They're crying. They can't steal anything from us. because the only traffic I will allow is exactly and only what I put in the whitelist. That's more work for me to do. I have to understand this and set it all up, but it's very powerful for security. AJ, I'm glad you had a eureka moment. We're in the light bulb business here. We like when eureka moments go off. So thank you for the comment there, AJ. Worded another way, again, if you do nothing with the whitelist, then everything is totally blocked in ACI and nothing will work at all. So somewhere between totally secure and not very easy, and real easy but not very secure, somewhere in there, every ACI architect needs to decide where's the sweet spot. Cisco doesn't decide that for you. The product doesn't decide that for you. You decide to meet your security requirements. Keep the bad guys out. Let the good guys in. Don't let any traffic go through that is not authorized. That's a good approach. And it's done by creating the whitelist in the MIT model. All right, team. On that note, thank you for the questions that came up. But over to you, folks. Any other questions? Oh, got it. Thank you. I see one there, Brad. Curious as to what firewalls you're using. Cisco, Palo Alto, F5, Checkpoint.
Yeah, so Chris, I kind of put that out to the attendees. I just wonder if they have their favorite firewall or load balancer. I noticed in your topology, you had an F5 listed there. And if you want, you can, those attending, just put it into the chat. I'm just from a curious point of view.
Sure, thank you.
Okay. And Chris, unless you want to say a couple of comments, something from the field, maybe you've got some experience, what works well, what seems to have a little bit more requirement for management maintenance. Any words of wisdom on that?
Sure. And by the way, also, AJ, please no need to apologize for zeal. I see your open question there. And I love the questions. They're very, very relevant. I see a note there for Checkpoint, Palo Alto, ASAs. Thank you, AJ, and others for responding on that. Appreciate your feedback. Good question there, Brad. And again, the cool thing about ACI is it can work with any of them. Only requirement, got an Ethernet cable.
Yep.
Once you have an Ethernet cable, you're good to go.
And Chris, we're going to wrap up in the next couple of minutes, but if you can go back to your topology slide and right there. So we're talking a lot about how you set up the different security side of things, but I wonder, have you ever had a problem where it was a physical cable in your experience? Because a lot of the times we make assumptions, right? And have you ever had something where just the wrong cable had a break in it or just wasn't connected right or something like that is part of troubleshooting?
Sure. Yeah, the answer is yes, of course. So that could happen. And so this cable here connected to the spine, as well as this cable here to its spine, is critical. Otherwise, this leaf would be isolated. So that is a valid point. But ACI makes it real easy to find that out and to fix it. And the reason is network management is built right in the APIC. Not only does this do the whitelist and everything for security, but also it's a full network monitoring tool and management tool. So you can see in ACI if these links ever one could go down. In the GUI, we'll actually show that. So if you identify that, then you go out physically, you fix it. I'll be honest with you, the majority of configuration errors are human in the whitelist, hence the key topic here of our seminar here. If the whitelist is not properly configured, then the hardware will look like it's broken, even though nothing is broken, because nothing is more important than the whitelist in ACI. But of course, we need the hardware and the cabling, as Brad correctly noted, to work. A valid point.
Okay, Chris, let's move on to the next slide there after the questions. And I want to thank you, Chris, and hope everyone has enjoyed today's webinar. If you'd like to learn more about this topic, we recommend these Cisco ACI courses. And basically what they do, they cover the implementations, there's operations and troubleshooting, which we just talked about, and advanced implementation, and also the automation side for those that are interested in the DevNet side from Cisco's side of things. Next slide, Chris. And as part of today's webinar, what we'd like to do is make it easier for you to take the next step. And we're offering you these discount codes, and you receive 25% off. Use the webinar 25 for US, and I'll even say roll that out to international folks. For Canadians, just put a CA in front of that. So CA webinar 25. And next slide, Chris. And again, social media, you can contact us in your favorite way of connecting socially. Visit Global Knowledge website. We've got additional free resources, technical articles, white papers, webinars. And with that, Chris, I just wonder if you have any last minute words of wisdom, and then we can close it off. And I want to thank everybody for joining.
Sure, yeah, thanks for joining. Just a comment, AJ, I see your question on demoing the app. Wasn't part of this webinar, but a detailed practice and use of ACI. We do that quite extensively in these courses. So these courses are not only all the detailed theory, but as well as a lot of hands-on with actual equipment.
And Chris, I don't know, is dCloud available to public at large?
The answer is yes.
Okay, I'm just going to put that in the chat, everyone, dcloud.cisco.com. AJ, do have a look at that. There are some, I'll call it sandboxes you can look at. Some of them are ACI, and might be some other ones that are interesting that you can look at. Okay, Chris, I want to thank you very much. Excellent seminar. I learned a couple of things myself today. Hopefully everybody enjoyed it, and remember to use our discount codes and join us and look at our webinars for the next ones that are coming up, and hope to see you all there soon. Thanks very much, Chris. Greatly appreciated.
Thanks, Brad, and thanks everyone for attending. You folks have a good afternoon.
Okay, bye for now.